Hey guys, welcome back to the channel. In this video, I'll be giving you guys a general understanding of factoring polynomials using this example submitted by my friend. If you guys want to have a problem you guys are stuck on submitted to the channel and possibly featured in a video, feel free to follow me on Instagram, YT_SwissArmyTutor. Comment on a post or DM me a problem you guys want me to use, and I check those DMs once a week. Also, you guys can email me the problem, the screenshot of the problem, and or the picture, and all details possible at YT_SwissArmyTutor, or sorry, the SwissArmyTutor@gmail.com, which both will be in the description below. Also comment down below how can I improve the channel, and also any feedback you guys could possibly give, and also any topics you guys want me to cover in future videos. So let's hop right into it. Okay, so we're given this function of p. P as a function of x is equal to x to the fourth plus 16x squared, and we're asked to factor it out completely and find all zeros. Okay, so so most people that I see, this is a common Algebra 1, Algebra 2 example, and most people I see really struggle with this. So this is a skill that you guys will need for calculus. So P of x, so let's just rewrite the problem real quick. X to the fourth plus 16x squared. Okay, so the first thing I do when I do these types of problems is I look for things in common. So remember the roots. So first we're going to factor completely. So they have x squared in common. So we take an x squared out. So that gives us x squared plus 16. Because if we, by the distributive property, we could distribute this. And we get the same thing. So P of x is equal to x squared times x squared plus 16. Now, this is where it gets a little confusing. All right. Most people would say this is prime. So in Algebra 1, Algebra 2, you guys would say this is prime. This is not factorable. But if we're extending to the complex root, complex roots, we could factor this. Sorry, guys. Okay, so all right, and the way it works, it's because if you guys remember, I is equal to the square root of 1. It is square root of negative I is equal to the square root of negative 1, which is technically undefined. And so pretty much what we're going to do here is this factors out to a difference of squares of x, so x plus 4i, x minus 4i. Alright, this is 4 times the square root of negative 1. This is minus 4 times square root of negative 1. And this turns out to be 16, x squared plus 16. Alright, so in factored form, I'll go more in depth of that in a future video. This is equal to, so this, bear with me, guys. Just take my word for it for now. We'll prove it in the next video, in a future video. X plus 4i. Okay. Now with that, we can find the zeros. With this factor completely. Sorry, guys. Let me move this over. Factor completely. Find the zeros. Alright, and the zeros of a function are also known as the roots. Is when f of x, or any function of x, is equal to 0. Okay, so we're going to set p of x equal to 0. Alright, so this is the first part of our problem done. Okay, so p of x is equal to 0. So we're going to fill in what p of x is equal to. So x squared times x minus 4i plus x plus 4i. Okay? And we set each piece equal to 0. Each one of these three pieces equals 0. So we take the square root of both sides. We find x is equal to 0. That's one root. Then we find, then we add 4i to both sides. X is equal to 4i. And x is equal to negative 4i. So what this is saying is there's only one real x-intercept. Sorry guys. There's only one real x-intercept in this. But if we extend it to the complex numbers, we have these two imaginary. But I'll explain what that means when we actually cover quadratics. But for now, pretty much what that is, it's just an imaginary root that really doesn't affect the function if we talk about the real number line. So our roots are x is equal to 0, x is equal to 4i, x is equal to negative 4i. Okay, and that'll do it for this example. So, like I said, guys, like the video, subscribe to the channel for more content. Follow me on Instagram, YT_the Swiss Army Tutor. DM me any problems you guys want me to cover with all of its details, or email me the same criteria, the Swiss Army Tutor at gmail.com. And also comment down below anything I could do to help you guys out by bettering the channel, and also any future topics you guys want me to cover. I'll see you guys next video.